The first method of factoring that we're going to consider is factoring using GCF, or greatest common factor. And remember, the whole key to factoring something with GCF is realizing that we're looking for what everyone shares in common. If we can figure out what everybody has in terms of numbers and variables, then we can just take that away from everyone and undo the multiplication and distribution that's been done. So let's look at a set of examples. First example, I'm going to take the binomial 14x squared minus 8x, and I want to factor him using GCF. So I go ahead and consider the variables and the coefficients, and I'll do the coefficients first. 14 and 8. I look at what can I divide out of 14 and 8, and here I get a 2. And then I look at the variables, x squared and x to the first, and I think how many x's do they share in common, because I'm looking for GCF, and they each have one x in common, so I can also pull out an x. So as I go to do this, I need to divide away the numbers and subtract off the exponents. So 14 divided by the 2 gives me a 7. I had 2 x's, I took 1 away, I'm left with 7x. Move on to the next piece. Negative 8 divided by 2 gives me a negative 4, and I had 1x and I took it away, so I get my final answer as 2x out front and then the binomial 7x minus 4. So what I did here was I factored using GCF. I pulled out what everything had in common. Now if I want to check my answer, remember factoring and distribution are inverses. So I could distribute the 2x to each of these pieces and see what I get. 2x times 7x gives me 14x squared, and 2x times negative 4 is minus 8x. So if these truly are inverses, I'll end up right where I started, which I do, which makes me very happy, because I used GCF correctly. But remember, my final answer when I'm factoring is this boxed in factored form, with the 2x out front and the 7x minus 4 on the inside. I can extend this type of thinking to a second example with a trinomial. So example 2, I have something like 4x to the third plus 16x squared minus 20. It's a cubic trinomial, and I apply exactly the same process. I look and I see, first of all, what do the coefficients share in common? So if I want to take something away from all of them, I'm able to take a 4, but nothing more. And then I look at the variables, and I see I have an x to the third there, I have an x squared, and I have no x's there. So if the third piece doesn't involve any x's, I can't take any x's from everybody. So in this case, my GCF is just the number 4. And then I go through and I divide him away from everybody else. So I'm left with 2x to the third plus 4x squared minus 5. And again, if I were to distribute this 4 the whole way through, I would end up getting back to where I started, because factoring and distribution undo each other. If I look at a third example, start with something like this cubic trinomial. Again, I'm going to follow the exact same process. In this case, I have a 4, a negative 6, and a 2. And I think, what can I pull out of all of those? And I can divide a 2 out of everybody. So then I take the next step and I start looking at my variables. I have 3x's there, 2x's there, and 1x there. So how many can I take from everybody? How many do they all share in common? Well, they all share 1x in common. So my GCF is 2x. So now I need to go through and just take a 2x away from all of these different pieces. So from the first piece, if I divide away a 2, I'm left with 2. Take 1x, I'm left with x squared. And then just repeat the process. I'm done with that piece. The negative 6 divided by a 2 gives me a negative 3. Take away one of the x's, I'm left with just x. I'm done with that piece. And at this point, a lot of people like to say, okay, on the third piece there's a 2x, I take away 2x, and I'm left with nothing. And this is going to be amazingly incorrect, because if I look at undoing this factoring using distribution, if I distribute my 2x to 2 pieces, there's absolutely no way that I can get the third piece of my trinomial that I started with. So I need to stop, go back a little bit, get rid of all of this that I did, and realize that I'm dividing the numbers away. So when I divide away a 2, I'm left with a 1. And the x's go away because I'm taking the x out, but I need the third piece to finish my trinomial. So when I begin with the trinomial, then I end with the trinomial. And now I've taken that piece away effectively. So my final answer here is the 2x out front, and then 2x squared minus 3x plus 1 on the inside. It's not to say that that's fully factored, but that's at least factored using GCF. Lastly, I can start with example 4 here and realize that this looks nasty and horrible, but if I focus in on just certain pieces of it at a time, it's not going to be too bad. So I start with these coefficients, 27, 9, and 18, and I realize pretty quickly I can pull a 9 out. And then I'm done with the numbers. So I go ahead and start going through the variables. I have x to the thirds there, I have x to the sixth, and x to the first. So how much do they share in common? Well, they all share 1x in common. Then just repeat that process. Go through the y's. There's 6 y's there, 8 y's there, 6 y's there. So what do they share in common? Well, they share 6 y's. Then repeat the process. Lastly with the z's. 4 z's there, 2 z's there, 3 z's there. So how many do they share in common? Well, they share 2. And that's my GCF, 9x y to the sixth z squared. So now I have to go through and just yank him out of all of these pieces. Remember, divide the numbers, subtract the exponents. So 27 divided by 9 gives me 3. Take away 1x, so I'm left with x squared. Take away all 6 y's, and take away 2 z's. I'm left with z squared. So I'm done with that whole piece. Then step on to the next piece. Divide by 9, I get a 1, which I'm not going to write. Take away one of my x's, so I left with x to the fifth. Take away 6 y's, that's y squared. And take away both of the z's, so they're gone. And I'm done with that piece. And then step on. Negative 18 divided by 9 gives me negative 2. I took away the 1y, I took away the 1x, I took away the 6 y's, and I took away 2 of the z's. I'm left with just z to the first. And that's my final answer. Started with a trinomial and ended with these 3 pieces in here, so I know that I'm at least correct in that sense. And if I were to distribute this 9x y to the sixth z squared back through, I would get back to where I started in my original. So in the end, my final answer is this factored form right here. I've taken something complicated and I've narrowed it down using GCF into something that's a little bit more manageable and easier to work with, which is exactly why I use GCF in the first place.